Hi friends, welcome to this video. The question is, a compound of Xc and F is found to have 53.5 percentage of xenon. What is the what is the oxidation number of xenon in this compound? Right. So they have mentioned this xenon. They have mentioned it is around 53.5%. Can you calculate how much percentage of fluorine is there? Because that compound contains only these two elements. These 200 means total elements will be 100. So fluorine will be what? 100 minus 53.5 percentage. That will be around C. 6.5 means 16. So it is 46.5 percentage of fluorine will be there. Right. So 53.5% of xenon and 46.5% of fluorine is there in this compound. Overall is 100%. Alright. So this is the thing. So let me make a chart. So the element are, so let me lay it here. Elements are xenon and fluorine, and the percentage we got 53.5% of xenon and 46.5% of fluorine. Next we need what? We need atomic mass. Atomic mass means A. So for xenon atomic mass, see in this question they should have given this xenon atomic mass and fluorine atomic mass. Fluorine atomic mass we can easily remember, up to 30 elements we can remember the atomic masses, but xenon they should have given, but they haven't given. So I have searched and got to know that the atomic mass of xenon is 131, whereas fluorine is, it is clear, right? Fluorine is easily 19. We can remember up to 30. So I tell you that to remember atomic masses, atomic mass you know, right? So if this X is the element, above we write atomic mass, below we write atomic number, right? So atomic number you should remember. There is a trick to remember, but atomic mass we have to remember for a few elements like bromine, chlorine, and 1 to 30 elements we have to remember those. But xenon, it is 131. If you can remember, just remember that is the atomic mass of what? Xenon, that is 131, right? So I have percentage, I have atomic mass. So what we can do, I can easily calculate what? Relative number of atoms. How to calculate number of atoms? Just divide percentage, 53.5 divided by 131. Similarly here 46.5 divided by 19. So here I'll get around it is 0.408. That is the relative number of atoms of xenon is how much? 0.408, whereas relative number of this fluorine is 2.44. This is nothing but, see, just if I remove this point here, it is 4 point something, right? Let us take it as 4. If I remove this point here, it is 24 point something. Just take it as 24. So it is 4 1 ja, 4 6 ja. It means here I'll get simplest ratio 1:6, right? It means what? Empirical formula. Empirical formula is nothing but xenon 1, fluorine 6. I can write it as XeF6. So this is the compound we'll get, whose empirical formula is XeF6, right? So how I calculate this? They have given percentage of this. Initially I found the percentage of fluorine. Later on, by knowing the atomic mass, I divided them so that I got a relative atomic number of atoms. Relative number of atoms means how many atoms are there in that atomic mass. That we got to know. And later on I got a simplest ratio. This is 1:6 is nothing but the simple ratio, or simple ratio we can call it as, that is 1:6. So XeF6 I got to, right? So XeF6. So we know the structure of XeF6 now. So XeF6 we will draw it like this: xenon, whose hybridization is sp3d2, and its shape is what? Octahedral. So it will be like this, right? So I have xenon and fluorine, 1 fluorine, 2 fluorine, 3 fluorine, 4 fluorine, below 1 fluorine, above 1 fluorine. So I know that fluorine is more electronegative atom, so it takes the electron density like this. So here -1, so it gets +1. Here also -1 gets +1, -1 +1, -1 +1, -1 +1, -1 +1. So oxidation state of xenon is, here it will be +6, right? Otherwise you can do like X plus 6 into minus 1 overall is 0. So x is equal to minus 6 is equal to 0. X is equal to what? Plus 6. So where x is the oxidation state or the oxidation number of xenon, right? So answer is D. So plus 6 is the oxidation state of xenon. So this is the question from some basic concept of chemistry, chapter 1 of class 11th, right? PUC first we call it as, right? So this is very important question. I hope this has helped you to understand the basics, how to calculate and all, and also how to calculate this oxidation number which comes in redox reaction of class first year only, that is class 11th, right? Thank you.